All right, so we're at part 2 here. Part 2 is where you're allowed a calculator, although you probably won't see me use one. Identify the zeros or multiplicities. Zeros are where you cross the x-axis, because you're probably listening to this without the audio, but where we cross the x-axis. And there's little things too. Let's go ahead and type that out, write that out. Zeros are where we cross the x-axis. Now, as far as multiplicity goes, a touch is at least once. Sorry, a touch is at least twice. Both start with a T. And a cross is at least once. Okay. So here's a 0. It's x equals -1. And it is crossing through the x-axis, so its multiplicity is 1. There's a 0 right here at x equals 1. It is bouncing off the x-axis, so its multiplicity is 2. And there's another one at x equals 3, which is also a touch, so its multiplicity is 2. Using turning point theorem, the polynomial is at least degree what? Well, all right, so the degree is the TP's plus 1. There are 1, 2, 3, 4 turning points. So if you take 4, we add 1, we're at least x to the 5th. That's how hard that theorem is. Based on end behavior, what is this guy? Well, this guy starts low and it ends high. All right. So, think about all the various things you've had. And I would say 90% of you guys, you at least get this right on a test. This is an x to the even. This is an x to the odd. Remember, I said write down whatever you need to write down. This is a negative x to the odd. And then you have this guy, which is a negative x to the even. Boy, I can't write worth a darn today. Anyways, this guy is behaving like this. It is a positive x to the odd. It is positive. Write at least your equation for the polynomial shown below in factored form. I'll type this to make it a little easier on y'all. So we'll just go with straight old y equals. There's always an a. We had this guy right here. This is x equals 1. The factor is x minus 1. And its multiplicity was 1. Then we have this one, which is x equals 1. The factor is x minus 1. Its multiplicity was a square. And then we have the 3, which is x minus 3, because when we enter parentheses, we change the signs. Now, in order to actually figure out what a is, you need that point right there. So we're going to plug in a 0 for x and 18 for y. 18 equals a times 0 minus 1 times 0 minus 1 squared times 0 minus 3 quantity squared. So 18 equals a times a -1, because 0 minus 1 is -1, times 1, because -1 squared is 1, times 9, because 0 minus 3 is -3, and -3 squared is 9. Gives me that 18 is equal to a -9a, which means a is -2. So I'm going to plug that in right up here. I'm going to change it over to calling it f of x, because it just looks nicer. Something's wrong. Oh, that's a plus. Well, phooey. Okay, so that makes that a positive 9a, which means a is 2. Hope you caught that before I did. Sorry about that. Not perfect today. There you go. Just plug in and go. There's your equation, kids. And remember, this was -1. You enter parentheses, it's +1. I actually didn't catch it down here because I thought it was weird that I was going to write x minus 1 cubed. But I caught it. I can't type these out for you, sorry. All right, find f over g of x and state the domain. That's going to be 3x minus 7. Sitting pretty over x squared minus 3x minus 4. So remember your rules here, 1 over anything. The anything is not 0. So x squared minus 3x minus 4 is not 0. Your favorite f word is a factor, or is 2-factor. Let's see, to make a -4, we need a -4 and a +1. A -4 plus 1 is -3, so x is not 4 by using the not zero product property, and x is not -1. So all values of x such that x is neither one of those two. The third one is, this number 3 is probably the harder one on this list. It's f times g. I say it's harder because, well, y'all are funny. It's not supposed to be hard. It's just the distributive property. We're going to 3x everything. So 3x times x squared is 3x cubed. 3x times the negative 3x is minus 9x squared. 3x times -4 is minus 12x. And then we're going to -7 everything. Man, go away. I don't want you there. I don't even know how to get rid of that. I don't do that. Oh, whatever. There we go. So a -7 times x squared is minus 7x squared. A negative times a negative is a positive, so 21x. A negative times negative is positive, plus 28. And then you combine like terms. There's a 3x cubed. -9 minus 7 is -16x squared. -12 plus 21 should be 9. And then we have the plus 28. And there's number 3. 4 is legit f plus g. You don't have to wrap when you do addition. It's just not going to gain you anything. So if we focus on standard form and like terms, there's an x squared. 3x minus 3x is nothing. -7 minus 4 is minus 11. Ta-da! 5 would be the one where we make our mistakes because we forget to wrap, and it is, pay attention order, it's g minus f. So it's x squared minus 3x minus 4 minus all of 3x minus 7. And distribute that negative, kids. That's -3x plus 7. So x squared, -3 plus -3 minus 6x, -4 plus 7 plus 3. And we have 6, we have our golf, which is g parentheses f parentheses x. So we're going to take this, it's going to go there. It's g of 3x minus 7. So g starts with an x squared. We're going to have 3x minus 7 squared minus a 3, and x isn't counted. It becomes 3x minus 7, and then minus 4. You know, if you're going to do 3x minus 7 squared, you're going to write it twice, and you're going to FOIL. That's 9x squared minus 21x minus 21x plus 49. -21 is -42. We're going to distribute our -3 minus 9x plus 21, and then the minus 4 along for the ride. Let's see here. We got a -42 and a -9. That should be -51x. We have a 49 plus 21, which is 70. And then take away 4 plus 66. And there you go. Oh, that's number 6. Third way down with the calculator portion. Solve the linear system below. This guy is straight up. Use a calculator. Matrices, double REF. And again, you take whatever notes you need to take. Write down whatever you need to write down. Plain and simple. Write down whatever you need to write down. All right, so where are we at? We're at second matrix. I'm going to scroll to edit. And what are the dimensions of this thing here? It goes rows and columns. We have 3 rows and we have 4 columns. And the first column is x's, the second column is y's, the third column is z's, and the fourth column is the result. Pay attention to the third row here. Notice it has no z. There's nothing there in the z column. All right, so we type everything in, we quit. We hit second matrix. We go to math. We're looking for that function called double REF. Its input is matrix A. Hit the wrong button, didn't I? Let's go through that process again. Second matrix, math, double REF. Second matrix, A. And here's your result. You just have to interpret it. Most of you guys, at least on the calculator portion of the test that I gave last time, you did pretty good. I had all the equations given to you. That probably had a lot to do with it. There's several of you, though, that still didn't do it. That says x is 1, y is 2, and z is 4. Ta-da! Factor all equations below completely. And there's our all free response. Notice it says completely. So I'm going to do this one. I'm going to pull the 16 because I can. If I pull the 16, I'll have x squared minus 4 because 16 times 4 is 64. Now x squared minus 4 is this pattern. Of course, so was the original. It's x minus 2 times x plus 2. Now, and it takes more steps, you still use that pattern right there, and you do 4x minus 8 and 4x plus 8. Now, I can pull a 4 from each of the factors on the inside. So this is 4 times x minus 2 times 4 times x plus 2, and then 4 times 4 is 16. It's actually quicker to pull that number from the get-go, but what do I know? I'm just a math teacher. All right, there's only one way to make a 7n squared. It takes a 7 and an n. Notice we focus on the front, then the back. Factors of 12 are going to be 4 and 3. I know 4 times 7 is 28, and 28 minus 3 is 25. Now let me check my signs here. That's a plus, so that's good. Because the outside is making 28n, and it is positive, and the inside is making negative 3n, and 28 minus 3 is 25. Factoring ain't hard. Number 10, to make an x to the 4th, you need an x squared and an x squared. You should know that by now. To make a 4, you need a 1 and a 4. You should definitely know that. It's got to be positive, and the sum has to be negative 5, so they're both negative. Now this guy, they're both actually special. X squared minus 4 is x minus 2 times x plus 2. And x squared minus 1 is x minus 1 times x plus 1, because it went back to that pattern right there. Didn't start as that pattern, but it went back to it. 11 is this pattern right here. 27u cubed is a 3u that's cubed, and you're taking away a 5 that's cubed. So a is 3u and b is 5. So I'm just going to follow that pattern. It says a minus b, 3u minus 5. Then it says a squared. So 3u squared is 9u squared. Plus because there's a plus, 3u times 5 is 15u. Plus because there's a plus, 5 squared is 25. Forgive me about drained and about done. Moving forward, solve using the quadratic formula. It's an Algebra 1 standard, by the way, you can do that. So quadratic form is x equals negative b plus or minus square root b squared minus 4ac all over 2a. A is 5, b is negative 14, and c is 6. All right. Opposite of a negative 14 is a 14, plus or minus the square root of a negative 14 that is squared. Notice the use of parentheses, minus 4 times a, which is 5, times c, which is 6. All sitting pretty over twice of 5. And then you figure out what you're dealing with, right? At least that's the way you were taught. So let's see what's in that radical. There is a negative 14 that is squared. We're taking away 4 times 5 times 6. There's 76 in that radical. And it's all over 2 times 5, which is 10. Now 76 is divisible by 4. I know you don't believe me, but maybe you believe me. You'll pull up the calculator. So, aha, told you. So root 76 is root 4 times root 19, so 2 root 19. So we have x equals 14 over 10 plus or minus 2 root 19 over 10. 14 over 10 is going to be 7/5. 2 over 10 is going to be something over 5 as well, root 19 over 5. All right, moving forward, 13, which is, this ought to be the easiest one on the test, but it's not. It says find all zeros by guessing or graphing. So let's graph. It says graph. You're holding a calculator. 4x 2z fourth plus 5x to the third plus 9x to the second. I know you're probably tired by now. So am I. If I'll live, you'll live. Pay attention to where your cursor is when you're playing along. That stinks. Plus 10x plus 2. Anyways, we're going to do a zoom 6. The way you were taught. Now, there's a nice 0. That something doesn't seem right about that. 4x to the fourth plus 5x cubed plus 9x squared plus 10x plus 2. I didn't see anything wrong. I'm going to throw in a 0 here. The reason I'm doing that is I'm pretty confident that's x equals -1. So second trace, 5. Get close, enter 3 times. It was -1. I'm pretty sure that one is something like a quarter or a third. You know, sometimes we just have to use the intersect feature. Get close, press enter 3 times. Yeah, it's -0.25. So those are from the graph. So from the graph, x equals -1 and -0.25, which by the way is -1/4. All right, the second floor gets your coefficients. I know on the test, I'm pretty sure there's a placeholder that's required. I feel like there is. Be on the lookout for that. -1 times 4 is negative. By the way, we're doing drop, multiply, and add. You drop the 4, negative 1 times 4 is negative 4, 5 plus negative 4 is 1, negative 1 times 1 is negative 1, 9 plus negative 1 is 8, negative 1 times 8 is negative 8, 10 plus negative 8 is 2, negative 1 times 2 is negative 2, 0. Notice how far I carry out the vinculum on the next line. I don't go all the way to the 0 because this is the remainder. I go here. This time I'm going to do the negative 1/4. I'm going to drop the 4. Negative 1/4 of 4 is negative 1. 1 and negative 1 add to 0. 0 times anything is 0. 8 plus 0 is 8. Negative 1/4 times 8 is negative 2. 0. Sweet. Remainder, constant x squared. That's why I stopped here. I reduced to a quadratic. This is 4x squared plus 8, and it's equal to 0. You can do the QF if you want, but you don't have to. I know that on your test, you do the QF. That's how it's done. It's done with QF because it has an x term. Anyways, I'm going to subtract 8 from both sides. I'm going to divide by 4. Then I'm going to counteract the square with a square root. So x is plus or minus the square root of negative 2, which happens to be imaginary. So plus or minus the imaginary root of 2. So there's 2 zeros. You got 2 from a graph. 2 plus 2 is that 4th degree up there. You know, you get half credit if all you can do is find the zeros off the graph. This is the one I think I talked about during instruction that kids would just miss like crazy. Number 1, find the inverse of this thing. It just says exchange x and y and resolve for y. So if I exchange x and y, it becomes 4y plus 8x, and it's equal to 16. I'm going to resolve for y, so that's the inverse. I'm going to resolve for y. 4y is negative 8x plus 16. Divide out the 4. So the inverse, y equals negative 2x plus 4. I just need to use correct notation. All right, what's up with this group? It says choose the correct diagram that has graph 4x plus 8y equals 16. Its inverse and the line of symmetry y equals x. Okay, so it says the line of symmetry is y equals x. That means this guy isn't it. This is y equals negative x. It's not what I'm after. So it could be A, C, or D. But I know I'm definitely not B. All right. I wish I had not just erased what I wrote, but the inverse was what? Negative 2x plus 4. So the only thing that has a y-intercept, I have to have y-intercepts of 4, which means this guy is not on the menu. So I'm either A or I'm C. This guy right here, this is positive slope. And that rise 2, run 1, I have negative slope. Choice C. All right, 15. Find the inverse of this thing. So let me write out the steps, or I'll type out the steps for you. Step 1, we swap x and y. Step 2, we resolve for y. Step 3, we use correct notation. These are really easy. You know, I talked about something though, and this is why inverses are so hard. Only 20% of all students in Tennessee can solve for a variable other than x. Like, that's how bad it is. And that doesn't mean it's okay that you can't. Because 80% of all students have what we call apathy. Apathy is don't know, don't care. Apathy is the problem. It's not the instruction you're getting, whether it's Mr. Milbrath or Miss Farmer, which it wouldn't be Mrs. Farmer, neither one of us. It doesn't matter who your teacher is. What matters is how you feel about the course and how relevant you think it is. And if you don't like modern mathematics, you need to realize what you would have without it, and it'd be a lot less. I mean, if you want to go full-blown Amish, go full-blown Amish. But you need to love math for what it has given you. You need to love it and appreciate it because it has given you more than it's taken from you. I promise you that. Has it made you feel kind of dumb from time to time? Sure. But what hasn't? All right, so find the inverse. We're going to do step one. We're going to swap x and y. That y becomes an x. This x becomes a y. And now we're going to do, so that step's gone. We're going to do step two, which is where we resolve for y. We're going to do the easy things first. Milbrath always says do easy stuff first. It's easy to counteract subtraction. Basically, going to isolate this mother function root. Now we're going to fix a square root by squaring both sides. And on inverses, I would not figure out what x plus 3 squared is. I would not do it. And one baby step and she's done. We're going to take away 2 from both sides. Now we're going to use correct notation. The correct notation is to call it the inverse of f of x. Because you can't just say it's y. If you just say it's y, well, I already have something called y, don't I? So you need to use the correct notation to let somebody know that it is different. Plain and simple. And there you go. That's 15. I think there's only 2 left. Cool. Find the inverse of g of x. It's the same exact steps. Here we're literally going to get the g out, make it an x. We're going to do all the easy things first. X minus 4 equals 2 times y minus 2 quantity squared. Do not worry about the square until you've done division. X minus 4 over 2 is y minus 2 squared. Now the opposite of a square shall be a square root. And we have y minus 2. Now we're going to add 2 to both sides. Use our notation. Now here's the kicker. This is only valid if x is greater than or equal to 2. You know, the very first thing I should have asked you was this thing 1-to-1? And it was not. If you don't know if it's 1-to-1 or not by looking at it, you ain't paid any attention all year long. Like something wrong with you. This thing is a right 2 up 4, and then it's a parabola. It was not 1-to-1. It failed the horizontal line test. So the way we fix that is to erase the left-hand side of it. And there's where the x is greater than or equal to 2. Perfect. All right, 17. Boy, I didn't put hardly any of these on there. I should have put some more of those on there. Solve x equals 5 plus 3x minus 11 to the 1/2. Identify the real zero. It does say you know your graphing calculator can do it. If you can't, we'll talk about that in a second. But we're going to take away 5 from both sides. X minus 5 equals 3x minus 11 to the 1/2. Going to do easy steps first. We're going to counteract the 1/2 power by using its reciprocal. The reciprocal of a half is to square. We square something by writing it twice. Right-hand side, we have cancellation. So x minus 5 times x minus 5 is x squared minus 10x plus 25, and it equals 3x minus 11. Going to shift everything left. X squared minus 13x plus 36 is nothing. To get to a 36, you need a 3 and a 13. No, you don't. You need a 3 and a 12. That doesn't work. You need a 9 and a 4. I want to be negative 13, so both negative. And this gives me x equals 4 or x equals 9 by the zero product property. All right. So you're supposed to identify the real zero and the extraneous one. So this was x equals 5 plus square root 3x minus 11, because the half power is a square root. That's what she is. So let's plug in a 4. 4 is supposed to equal 5 plus the root of 3 times 4 minus 11. That's going to be square root of 1. And 5 plus square root of 1 is 6. 4 equals 6? No. This guy is extraneous. Plug in the 9. 9 equals 5 plus square root of 3 times 9 minus 11. Seems like 3 times 9 is 27. 27 minus 11 is 16. 5 plus root 16 is 9. So 9 equals 9. True. 9 is real. Now, I did say, your calculator can do the first part for you. Your calculator can do the first part for you. You can go right to y equals. You can put an x in y1. And if you don't know that's a square root function, it's no big deal. You can type 5 plus parentheses 3x minus 11. Raise it to the 1/2. Zoom 6 it. Remember, solutions happen where graphs cross paths. So there's an intersection right there. Second trace 5. Enter, enter, enter. It's at 9. Now, remember our extraneous solution was where x was what? 4? Let's type in the conjugate of that funny thing. The conjugate of 5 plus the square root is 5 minus. And I might be really tired and this doesn't work, but I think it does. Yeah, the conjugate of the funny expression will get you the extraneous solution. So there you go. You're probably the only class in the state of Tennessee who's been shown that. You're welcome to have me as a teacher. You really are. And there you go. There's that twin. All I gotta do is make a whole bunch of copies.